Welcome to the first section in this complete Node.js bootcamp. And in this section, we will take our very first steps with Node.js and its core modules by building a small and fun project. So my goal with this section is to get you writing Node.js code as fast as possible, but without worrying too much about how everything works behind the scenes, because that will follow in later sections. So we will start using a lot of new concepts all at the same time here. And so don't worry if you don't understand all the technical details right away. That's just completely normal, all right? Anyway, let's now get started on this journey. Now, before diving into some Node.js code, let's do a high-level overview of what Node.js actually is, what we use it for, and why we use Node instead of other technologies. So, the official definition is that Node.js is a JavaScript runtime built on Google's open source V8 JavaScript engine. Now, what does that actually mean? Well, let's start by trying to understand what a JavaScript runtime and the V8 engine actually are. So you have probably already used JavaScript before, and it was probably always just inside a browser, right? Because any browser natively understands HTML, CSS, and JavaScript. And no matter if you write vanilla JavaScript or some JavaScript framework like React or Angular code, that's all just JavaScript that gets executed right in the browser. So in this case, the browser is then the JavaScript runtime. But what if we could take JavaScript out of the browser and simply execute our JavaScript code somewhere else without all the restrictions that we have in the browser? Well, it turns out that we actually can. And the solution for this, as you can guess, is called Node.js. And so Node.js is just another JavaScript runtime. It's just like a container, like an environment in which a program written in JavaScript can be executed, but outside of any browser whatsoever. Alright? It's actually a bit more complex than this, of course, but for now, this is enough. Now, who actually does execute the code if not the browser? And that's where the V8 engine developed by Google comes into play, because that is exactly where JavaScript code will be parsed and run in Node.js. Okay? So I hope that now the definition of Node.js being a JavaScript runtime built on the V8 JavaScript engine makes a lot more sense. And again, this is just a very high-level overview of what Node is and how it works. We are going to go into a lot of detail about how Node really works behind the scenes right in the next section. But at this point, I just want you to get a quick overview so that you can start learning the fundamentals of Node.js in practice throughout this section. Anyway, now that we have JavaScript outside of the browser, in a kind of standalone environment, which is Node.js, we can do so many more things with JavaScript that were completely impossible before, like accessing the file system or better networking capabilities are now possible with Node.js. And all these factors together give us the perfect conditions for using Node.js as a web server, meaning that now we can finally use JavaScript on the server side of web development in order to build fast, highly scalable network applications for powering the backend of our websites or web applications. And this is absolutely fantastic and game-changing for web development. So let's now take a look at some use cases for Node and why it's such a great fit for backend development. And the first thing that we need to talk about is the fact that Node applications are so fast and so scalable because Node.js is single-threaded and based on an event-driven, non-blocking I/O model, which makes Node.js very lightweight and efficient. Now, that of course sounds super complicated, I know, but once more we're going to talk about exactly what all of this means a bit later in the course. But for now, just keep in mind that Node is perfect for building super fast and scalable, data-intensive web applications. And that makes Node.js a perfect fit for building all different kinds of applications, like building an API with a database behind it, and preferably a non-relational NoSQL database like MongoDB. And this is actually exactly what we're going to do later in this course as we dive deeper and deeper into Node.js. But there is, of course, all sorts of other apps that we can build, like data streaming applications such as YouTube or Netflix, real-time chat apps, or even server-side web applications where the entire content is simply generated right on the server. So as you see, the possibilities really are endless. But there is actually also a type of apps that we should not build with Node. And this is when our app needs some super heavy server-side processing, like heavy image manipulations, video conversion, file compression, or anything like that. Alright? And you will learn why that is once we dive deeper into how Node actually works. So in this case, we're better off using something like Ruby on Rails, PHP, or Python, because Node.js just wasn't developed for these use cases. And although there are solutions for dealing with them, we should always use the right tool for the task at hand. Okay, so these are the types of applications that we can and cannot build using Node.js. And if you choose to use Node, well, then you are in good company, because many top companies like Netflix, Uber, PayPal, eBay, and many more have already started using Node.js, which really proves that the technology is stable enough at this point to be used in production. Now, of course, there are more reasons for using Node, and the biggest one is probably that using the same language across your entire stack, both on the front end and the back end, is a lot easier for you or for your team. First, you don't have to learn a new programming language for building your backend, and also you don't have to keep switching back and forth between languages, which will make the entire building process faster and more efficient. Believe me, it's really amazing to be able to use JavaScript to build your entire application from start to finish. It's absolutely fantastic, really. And another great reason for using Node is that there is a huge library of open source packages, or modules as we can also call them, available for everyone for free. It's called NPM, and you've probably heard of it or even used it already. And of course, we're also going to start using packages right in this section. And finally, it's also good to know that there is a huge active community of Node developers out there that are constantly improving Node.js and helping beginners like you. And so you can really rely on the technology for all your projects in the years to come. Okay, so that was a very brief intro and overview of Node.js and some of its use cases. So for the rest of the section, we will now use Node to create a very simple web server and build an extremely simple API so that you can get familiar with the basic principles of Node development. Welcome back. So I hope that you have Node installed on your computer at this point. And so let's now actually go ahead and use Node for the very first time. And to get started with this section, please go into the course starter files and copy this folder to your working directory. Okay? Now, if you didn't download the course files yet, please go to the GitHub repository that is linked all over the course, and you will find all the files that you need in there. Then after that, go ahead and open up the folder in your code editor. And I'm using VS Code here, and I actually already loaded it up. So here is this Node farm folder. Now in this video, we will actually not yet start with the project, but instead we're going to interact with Node using the command line. And for that, I'm going to use the built-in terminal that VS Code has, hitting Control backtick for that. So this command that you see here actually, or you can go to View and Terminal. Now if you prefer to use another application for the terminal, that's fine as well, but throughout this course, I'm always going to use the terminal that is built in right into VS Code, so that we don't have to jump around between different windows so much. Now, to start writing some Node code here in a console, all we have to do is to write Node, given that you have Node.js installed on your computer, and then just hit enter. And this will then open up the Node REPL, which stands for read eval print loop. So basically here we can write JavaScript code just like in a normal terminal. For example, we can define variables, and so here it is. So we just defined the name variable, and in fact we can write any JavaScript code that we like in here. Okay, so that's because at the end of the day, Node.js is really just a JavaScript runtime, as we just saw before. So what else can we do? Well, any type of expression really will work. Let's just do some math here, for example. Okay, so any JavaScript will work. And you see that we actually defined this variable here using const. So that is ES6. And that is absolutely no problem in Node.js. So it supports ES6 in all the newer versions out of the box without any problem. That's because we're not running this JavaScript in any browser, but it will always run on the server. Okay, so in fact, we just took JavaScript out of the browser and we're running it inside of this Node application. Now, if we wanted to exit this REPL, so again, this read eval print loop that Node gives us, there are different ways of doing that. The first one is to write exit, or actually .exit. And so this exited this Node process, this REPL. And so let's start it again so that I can show you some more stuff. So again, just type Node, hit enter, and that's it. Oh, and by the way, if you want to clear your terminal like I just did, all you have to do is to hit Command K, and that will then clear up the command line. And probably on Windows, that is Control K. Okay. Anyway, we used .exit to exit the REPL, but we can also hit Control D. And that's not command, it is really control. So Control D will do the same. But let's quickly enter it again, because there's some more stuff that I want to show you. So if you hit tab right now, maybe you have to tap it twice. Sometimes that happens for some reason. But anyway, by hitting tab, you can see all the global variables that are available in Node. So you have all the kind of stuff that we're already used to, like the array constructor or the string constructor or math or a number over here. But then there's also all kinds of stuff that belongs to Node. For example, you have HTTPS and FS or crypto, and these are Node modules that we're going to talk more about a bit later in the section. But for now, you see that we have all kinds of global variables that we can access whenever we want in Node.js. Okay? Also, another nice trick is the underscore variable. So let me first show you something. So another calculation, for example, 3 times 8 gives 24. And now we can use underscore plus 6. And so this will give us 30. And so that means that underscore is basically your previous result. So we had 24, and so underscore here is 24 now. And 24 plus 6 makes 30. So if we now did underscore minus 30, that will give us 0, right? And yeah, it did. Okay, and finally, the tab that you just pressed before, you can also press that for example, on one of these constructors that we already know, like string. So string dot, and now by hitting tab, you can see all the methods or properties that are available to us. Again, sometimes you have to hit it twice, but then here we are. So you have, for example, the length or has on property, and all these kinds of methods here that we know already, right? And now to exit the REPL, remember all I have to do is to hit Control D. Okay, then Command K to clear the console, and that's it. So that's all I wanted to show you in this very first video. So basically that we can write JavaScript now outside of the browser using Node.js like this. let's keep moving and explore Node.js some more. And so let's now actually start a new JavaScript file. So right in the root folder, and I'm calling it index.js. Let's just decrease the terminal here a little bit. Okay, so let's now write our very first Node code here inside a file. And all I'm going to do is to create a hello variable and then putting the classic hello world in there. So hello world has been traditionally used when starting a new programming language, and that's kind of what we're doing here. Okay, and now I'm logging to the console this hello variable. So very simple stuff. Give it a save, and let's actually now run this file. So in normal JavaScript in a browser, we would now include this JavaScript file into some HTML file and then open up that HTML file in a browser, right? But here with Node, we don't need to do anything like that. All we do is to use our node command. But now we're not going to hit enter right away because that would take us back to the REPL. But instead, we want to run this file. And so all we have to do is to write node and then the name of the file, so index.js, hit enter, and indeed, here we have our log, hello world. So congratulations, you just run your very first Node script. Now, that isn't really all that useful, is it? So let's do something a bit more advanced. And remember how I said right in the first lecture that with Node.js we can do all kinds of amazing things that we cannot do with JavaScript in the browser, like for example reading files from the file system, right? Now in order to do that, we need to use a Node module. So Node.js is really built around this concept of modules where all kinds of additional functionality are stored in a module. And in the case for reading files, that is inside the fs module. So how do we open up these modules, or how can we actually use them? Well, we do require them into our code and then store the result of the requiring function in a variable. So that sounds a bit complicated, so let's simply do it. So we will call fs to the result of requiring the fs module. And fs here stands for file system. So by using this module here, we will get access to functions for reading data and writing data right to the file system. So again, calling this function here with this built-in fs module name will then return an object in which there are lots of functions that we can use. And we store that object right into the fs variable that we can then later use. We are going to use it in the next video, but for now I want to quickly take a look at the Node documentation with you, so that in case you need some other module for yourself later, you always know where to look up some information about it. Okay, so the Node documentations are something really important for every Node developer to know about. So what we do is to go to nodejs.org and then hit the Documentations tab here, and then select the Node version that you're using here on the left side. So I'm using version 10, and so that's the one I'm choosing here. And so that is the documentation. Here on the left side, you have all kinds of different modules. For example, you have the REPL as well. So the REPL is what we used in the last lecture. And if you need to know a bit more about it, well, you can come down here and read whatever you need to know. For example, the exit that I talked about is documented here, and well, all kinds of stuff. Okay, you can also actually use the REPL inside your code, which doesn't make much sense, but it is actually possible. So again, all the modules are listed here on the left side, and the one that we just implemented is the file system. Okay, and so down here you have all this different stuff that for now will not make much sense to you, okay, but that's no problem at all. That's why we have this whole course ahead of us. For now, just know that in case you need anything, it is always available in the documentation for you. So, for example, in the next video, we will read a file from the disk to our code. And we're going to do that using the read file sync. And so here you have all the information about that specific function. Okay, and so in the next video, that is actually what we're going to do. And in this one, you learned how to write your own very first Node code inside of a new JavaScript file and then run that file in the terminal. Then we also required the file system module. And so again, in the next video, we will finally use it and import some files. See you then. This is a really exciting lecture because you're going to learn how to read data from files and also how to write data into files. And we already imported the built-in module that we need for that in the last lecture. And so let's now get rid of this code and start using the fs module. So we use fs.read file sync. Okay, and sync stands for synchronous. And you will start learning about synchronous and asynchronous right in the next video. Okay, so this is the synchronous version of file reading, and there's also an asynchronous version. So the read file sync function takes two arguments. The first one is the path to the file that we're reading, and then also the character encoding. So first the path to the file, and the file is in the txt folder, and it is the input one. So this text that I have here about the avocado is what we're going to read into a variable. And I'm not sure if you're going to be able to see this emoji here right on your operating system, but if you're on Windows 8 or Windows 10, then that's probably going to work just fine. Okay, so we specify the path there, and there are multiple ways of doing that, but for now I'm going to go with the simplest one. So all I'm going to do is that it's in the /txt/input.txt. So again, we're starting at the home folder, which is basically the folder where the index.js file is located. So that's the dot in there. And then we move into the txt folder, and from there input.txt. Then here the second one, we have to define the character encoding, which is UTF-8 usually, at least if you're just using English. Okay, and if we don't specify this, we get back something called a buffer. Okay, and that's not really what we want. We really just want the text. And so calling this function here will now read the data from the file and return it to us. And so we need to save that somewhere, and we put it into a variable. So let's say text in, because it's our text input. Okay, and then let's log it to the console just to see if it works. Give it a save, and now we need to run this here again. So in the terminal, I can just use the up arrow to run the previous command. So here is node index.js again, hit return, and let's see. And indeed, here we go. So here is the content of that file. So perfect. We now know how to read stuff from files. Congratulations. Okay, but we also want to know how to write to files. So let's create some new variable here with some more text and then write that into a new file. So let's call that one text out, so for output. And basically let's just write a string where we will then include this text in. And I'm using a template string here. And at this point, I'm going to assume that you're kind of familiar with the ES6 syntax. Okay, so we already used const here, which is an ES6 way of declaring variables instead of var. and now the template string, which is another ES6 thing. So before ES6, if you wanted to add something to text in, you would have to use the plus operator. So let's say this is, and then space, and then text in. Okay, so you would have to use the plus operator, but with the template string, it's much easier. All we have to do is to use the backticks, then some text, and then into this string, you can very easily plug in the variables. So let's say this is what we know about the avocado. Then we use this syntax to input the variable. Okay, and so basically inside of these curly braces here, we can write any JavaScript that we want. So it's not just for plugging in variables straight away. We could also do like calculations or any JavaScript expression that we wanted in here. Now let's say a new line character. So that's a new line, okay? And just to show you that we can actually use JavaScript inside of these curly braces here. So this $sign and then curly braces. So date, or actually date like this, dot now. Okay, so that is our string, which has this text here and together with the text that we read before from the variable. And so now let's write that to a new file. So again, we use the fs module, and this time write file sync. Okay, and again we specify the path to the file, and we still want it in the txt folder, and we call it output.txt. Okay, and now we have to actually specify what we want to write into that file, right? And that is the text out variable. And this doesn't return anything meaningful, and so we don't save anything to any variable. All we do is to finally log something more to the console, like just informing that the file has been written. Okay, so let's test it out again. I'm going to clear the console with Command K, hit the arrow up key, enter, and maybe you saw it, we here now have this new file called output. And if I open it up, then you see this is what we know about the avocado, which is what we wrote in the index.js, and then this is the text that came before from the input file, right? Then the new line that we created, and then created on this date basically. So this is date.now, so just a time stamp in milliseconds. All right, and this is how you read and write to and from files in Node.js. Let's now take a minute to learn about the asynchronous nature of Node.js, which includes absolutely fundamental topics like synchronous, asynchronous, blocking, and non-blocking code. And all of this will be really important in order to understand everything that's coming up throughout this section. So this piece of code that we wrote in our last lecture to read a file and then save its content into a variable was in a so-called synchronous way, which simply means that each statement is basically processed one after another, line by line. In this example, first the file system module is required, then the file is read, and then we log the result to the console. So you see that each line of code basically waits for the result of the previous line. Now, this can become a problem, especially with slow operations, because each line blocks the execution of the rest of the code. And so we say that synchronous code is also called blocking code, because again, a certain operation can only be executed after the one before has finished. And because of the way Node.js was designed, this turns into a huge problem, as we'll see in detail in the next slide. So the solution to this problem in Node is to use asynchronous non-blocking code. So in asynchronous code, we offload heavy work to basically be worked on in the background. And then, once that work is done, a callback function that we registered before is called to handle the result. And during all that time, the rest of the code can still be executing without being blocked by the heavy task, which is now running in the background. So what this means is that we can effectively defer our reaction into the future in order to make the code non-blocking. And this is of course much better. Make sense? So in this example, we use the asynchronous read file function, which accepts a callback function. This will start reading the file in the background and then immediately move on to the next statement, printing to the console the string reading file. So again, you see, we are not blocking the execution here. Then, when the file is finally completely read, the callback function will be called, and so the data that was read will then be printed to the console. So that's quite different from the synchronous version, isn't it? Now the question here is, why does it actually have to be this way? What's the problem with blocking code execution in Node.js? Or in other words, why do we actually use callbacks so many times in Node.js? Well, let's find out. And in order to understand these questions, the first thing that we need to understand is the fact that a Node.js process, which is where our application is running, there is only one single thread. And a thread is just like a set of instructions that is run in the computer's CPU. So basically, the thread is where our code is actually executed in a machine's processor. So remember, Node.js is basically single-threaded. And so for each application, there's only one thread. That's just the way Node.js was designed. Now, what that means is that all the users accessing your application are all using the same thread. So basically accessing the same thread. And so whenever they are interacting with the application, the code that is run for each user will be executed all in the same thread at the same place in the computer running the application. And that is true no matter if you have 5 users, like in this diagram, or 5,000 or 5 million. Alright? Now, what this also means is that when one user blocks the single thread with synchronous code, like we just saw before, then all other users will have to wait for that execution to finish. And that might not be a huge problem if you have like 5 users, but it definitely will for thousands or even millions of users at the same time. So imagine there's a user accessing your application and there's a huge synchronous file read in your code that will take like 1 second to load. This will mean, of course, that for that 1 second, all other users will have to wait, because the entire execution is blocked for that 1 second. So if the other users want to do some simpler tasks, like logging into your application or just requesting some data, they won't be able to do so. They will have to wait until the file is finished reading. Only when that happens, they will finally be able to perform these simpler tasks, one after another. Now, please note that this is a very oversimplified version of what really happens behind the scenes of Node.js, which is why we will come back to all of this in the next section and get an even deeper understanding of how Node.js handles asynchronous code under the hood. But at this point, this is enough for you to understand the concept. It's better to go step by step here and not make it too confusing right from the beginning. Okay? Anyway, this is how the situation would play out with synchronous blocking code, which is obviously a terrible experience for your users. And so it's really your job as a developer to avoid this kind of situations by using asynchronous code. So for the same situation, we should of course use the asynchronous file read function, which instead of blocking the single thread, does the heavy work in the background, where it basically stays until it's finished reading the data from the file. Of course, we then also register a callback function to be called once the data is available. And in this scenario, all the other users can then perform their tasks in a single thread, one after another, while the file is still being read in the background. Now, once the data is read, our callback function will of course get called to be executed in a main single thread in order to process the read data. And that's it. That's an overview of how Node.js handles asynchronous behavior in order to implement the non-blocking I/O model that we talked about in the intro lecture. Alright? And I/O simply stands for input-output, which is basically stuff like accessing the file system and handling network requests. This is actually the whole reason why Node.js is completely designed around callbacks, as you will see throughout the course. In other programming languages like PHP, it works very differently, because you get basically one new thread for each new user, which is a completely different paradigm and really works completely different. But the creator of Node.js found this model to be the best solution for building highly performant and scalable web applications. Now, just as a final note here, it's important to know that when we use callbacks in our code, that doesn't automatically make it asynchronous, alright? So passing functions around into other functions is quite common in JavaScript. But of course, again, that doesn't make them asynchronous automatically, okay? It only works this way for some functions in the Node API, such as the read file function, and many more, as we will explore in the future. And now just to finish, since we're talking about asynchronous code here, just one last note about callback functions. So this callback model that we just discussed, where one function is called once the one before has finished its work, can quickly lead to some hard to read and unmanageable code. Just take this example where the second file read depends on the first one, then the third file read depends on the second one, and finally, we want to use the final data to write a file as a result. That looks quite confusing, right? I mean, it's gonna work just fine, but it's just hard to reason about. And that is just with 4 levels deep. Imagine you had like 10 or 20 levels, which is actually not that uncommon. Anyway, this is what we call the callback hell. It is such a common problem that it already got its own name. And do you notice this triangular shape here? That's a very clear sign that you're in callback hell. Now, how do we actually escape callback hell? Well, we can use more advanced tools for handling asynchronous code, like ES6 promises, or even better, ES8 async await. Now, the model that we just talked about will still be the same, we just have more elegant ways of dealing with the code itself and writing it. And there is a whole optional section a bit later in the course on promises and also async await, so in case you're not familiar with them. But for now, we will keep using callbacks because that is what Node originally used and was designed around. And now, with that being said, let's move on and use this asynchronous model in practice for the first time. Welcome back. In this video, we're going to read files and write 2 files just like before, but instead in an asynchronous way. So let's add some comments here before. So this is the blocking synchronous way, and then we will do an exercise in a non-blocking asynchronous way. So we're not going to do the same thing, we're just going to invent some other kind of crazy exercise here. So to read a file in an asynchronous way, it works like this. Again, we need the fs module, and then read file, but this time not read file sync, of course. And again, we pass in the name of the file, or the path to the file actually. And so again, it is at txt, and the file that I want right now is called start.txt. So this one. Oops, sorry for that. So this is the file that I want. All the task is read this, and I'm going to explain to you why a bit later. For now, don't worry about the content here. So in the read file, we actually do not have to specify the file encoding. Okay, and so the next parameter, the second one, will be a callback function. And that is what we learned in the last lecture. So Node.js is all built around callbacks in order to implement an asynchronous behavior. And this is how it works. So Node will start reading this file here in the background, and as soon as it is ready, it will then start the callback function that we specify here. Okay, and it calls this callback function with two arguments. The first one is the error, and the second one is the actual data. Okay, so this error first callback style is very typical in Node.js. Okay, so many times the first parameter in a callback will be the error in case there was any, and the second one will then be the data itself. What matters here is that the error is usually always the first one. Okay, and so just to test it out for now, let's simply log to the console the data. And so let's now actually test that. But before we do this, let us actually still specify the file encoding here, okay? So I'm not 100% sure that it works without this. So clean this now, run it again, and here we see read this. So let's analyze again what happened here. So as soon as this function here is run, it will start reading this file in the background without blocking the rest of the code execution. Okay, so let me actually demonstrate this here. So a console.log will read file, and just to have a bit less confusion there, let me comment out this part here. Okay, and so what do you think will happen now? What log are we going to see first? And indeed, first we see will read file, and only then we see read this. So again, why did that happen? So as I mentioned, Node.js will start reading the file in the background here and will not block the code, and will then immediately move on to the next line of code. And the next line of code, well, it's this log here. And so that is the first thing that will be logged here to the terminal. Only then, when the file is completely read, this callback function here will run. Okay? And again, this callback function has access to the error and the data that was read. And we could really call this here anything that we wanted. We could call it text as well. It doesn't really matter. All that matters is that it is the second argument in this callback function. Let's actually go back to data, because I like that way better. And so only then this second console.log will run with the data, so with the text that was in the file. And so that's why we see this here as the second log. All right. Now to take it even further, let's actually do another read file, but instead of this, so that I can show you how we can basically do multiple steps one after the other with callbacks. So steps that depend upon the result of the previous step. Okay, so that is why actually in this start file I have read this, because then there is a file called read this, which has the content that we're actually interested in. Okay, so what I'm going to do here is to copy this code and put it in here. I'm going to call this one data1 and then data2. And the result of the second step, so the second file read, will depend on the first one. That's because we will use the data for the file name. Remember? So here we are doing a template string now, because we need to put in that variable, and it is called data1. Okay, makes sense? So data1 will be read this. Okay, and so then in the next step, we read txt slash read this dot txt, which is then this. Okay, so that's why this file name here is the same as this content. And so let's log to the console data2 then. And let's quickly test if this works. And indeed, so that is the content of read this.txt. And now I'm actually going to take it one step further even, because there's some other text in this append file that I want to add to this first string. So this text coming from the other file. And so we have yet another step that depends on the previous step. And so what I'm going to do is to add another read file in here. So just like this. So this one is called append. And I'm going to call this one the data3. Data3 here. And so let's again run that. And okay, so now we have these two results here. All right, and now finally, as the last step, I want to write these two strings together into a file. Okay, so far we have only read files, but I want to write a file as well. So let's do that right here as well. So fs.write file, and of course, we're not using the synchronous one like we did before, but again, we use, just like here and here and here, we use the asynchronous version, not the synchronous one. So txt slash, missing this one here, final, then we should add the text encoding here as well. And then this one also accepts a callback function. But in this case, there is no data that we read, and so we don't need two arguments. So the only argument that we have is the error, actually. Okay, so here we have the error and the data that was read, but here in write file there is no data. All that there is, or can be, is an error. Okay, and actually we're missing something here, which is what we actually want to write to the file. Okay, and so that is the second argument. And what that is data2 and data3. So again, a template string here, data2, then a new line character, which again is \n, and then data3. All right. And so just like with the read file functions, then this callback is what's run at the end. So what I'm going to do here is to simply log to console that the files have been written, or that the file has been written. Your file has been written. And let's just use some fun emoji here just to make the console a bit brighter for us. And I think we should be done like this. So let's clear the console one more time, run it. And indeed, we see your file has been written. So has it really? Final? Oh yeah, here it is. So that is the read this text and the append text both together, both in the same file. Okay, so that is how we perform multiple steps in orders using callback functions, right? Because imagine that you simply did the same file read and then the second file read, so this one, right after that. Well, how would you then get access to the data from the first one, right? And so that is how this pattern emerges. It actually has its own name, and I think I mentioned that in the last video. It is the called callback hell, and there are some solutions to make this code here more readable and better to understand. But for now, that doesn't matter at all for you. What matters is that Node.js is built around this philosophy of callbacks. So that is how Node.js implements asynchronous operations, by calling callbacks as soon as the operation that it's doing has been finished. And by the way, this way of writing functions that you see here, again, in case you're not familiar with it, it is the new ES6 syntax as well. Okay, so again, I hope that you are familiar with ES6 at this point, and so that all of this makes complete sense to you. If we were to write this function here without the arrow function syntax, we would do simply like this: function arr data1, and then like this. So that is a normal function, let's say an old-fashioned function, and the new version works like this. The difference between them is mainly the syntax, but also the fact that an arrow function, so this kind of function, doesn't get its own this keyword. So it uses the this keyword from the parent function, and that is called the lexical this keyword, while a normal function like this one always gets its own this keyword, right? I'm sure you're familiar with that kind of stuff, but just doing a small review here in case you're not. Okay, I hope that made sense. We did actually never use this error here. We didn't handle any errors. So for example, imagine that this file here did not exist. Well, we could then use this arrow. And let's actually do that, but just for this one here. So I don't want to create all of these error handlers here. But just in this situation, let's say there was an error. And so let's say if error, then return from this function, so do nothing else, and log to the console error. And then we can add some other emoji here, like this explosion, so like something exploded here. So let's now change this here, like start.txt, run this again, and so we have this error now. So it gives us this log to the console, and since we did return, it will not do anything after that. So all of this is basically ignored and will not run, which is exactly what we want, right? But if we put it back to normal and then run it again, well, then everything works just like before. So get used to this pattern of callbacks, because you will see it all over the place in Node.js and throughout this section. This video is yet another really exciting one, because now we're gonna create our very first real web server capable of accepting requests and sending back responses. And the first step is to include yet another package or another module, okay? And this one is called HTTP. So we're using the require function again, and then requiring the built-in HTTP module. And that's the one that gives us networking capabilities, such as building an HTTP server. Okay? Now let's actually comment out this code here so that it doesn't get in our way. Okay? So let's actually create kind of a divider here. So this one is for files, and this one is for server. And now, in order to build our server, we have to do two things. First, we create the server, and then second, we start the server so that we can actually listen to incoming requests. Okay, so we use our HTTP module, and just like before, we use a method that is on that object. So just like we did with the fs module, right? So http dot create server. And create server will accept a callback function, which will be fired off each time a new request hits our server. And this callback function gets access to two very important and fundamental variables. It is the request variable and the response variable. And a little bit more about them in a second. So request and response. And so all we want to do now is to actually send back a response to the client. And we do that with res, which is this object here, this response object, dot end, and then hello from the server. So that is the response that we're going to send back. So again, each time that a new request hits our server, this callback function here will get called. And the callback function will have access to the request object, which holds all kinds of stuff like the request URL and a bunch of other stuff. On the other hand, this response object here gives us a lot of tools basically for dealing with the response, so for sending out the response. And the simplest one is .end. And this .end here, the naming of this method, will make a bit more sense a bit later. For now, just note that this is the simplest way of sending back a very, very simple response in this case. Okay, so that's really all we have to do to send back a plain text response when a certain request comes in. Now, if you're a bit confused about all these terms, like incoming request or sending responses, or even about why we do actually have requests and responses here on our server, then don't worry, because we have a whole lecture coming up about how the web works, where we're going to talk all about the client-server model and really how network applications work in general. Again, in this section, my main focus is on actually showing you all this stuff and really making it work, and then the theory will follow a bit later. Okay, so that's the philosophy I've used in all my other courses, and it's been working really well, and so I believe it's a good thing to do it here as well. Anyway, creating the server was the first part, and now the second part is to actually listen to incoming requests from the client. Okay, now in order to do that, we actually need to save the result of this create server here to a new variable. So we call it usually server. So server is the result of this create server method here. Okay, so it will create a server, and now we use that server, and on that we can call listen. And listen accepts a couple of parameters. The first one is the port, and usually the port that we use in Node is, for example, 8000, but you will see other numbers like 3000 or 80 or something like that. And in case you're wondering what a port actually is, well, it doesn't really matter, but all you need to know is that it's basically a sub-address on a certain host. And the host is what we specify next. Okay, we actually don't need to specify it, and then we'll default to localhost, but we can actually specify it also to localhost explicitly. So localhost usually has this address as a default, and localhost simply means the current computer, so the computer that the program is currently running in. And again, this is the standard IP address for that localhost. Okay, so this one here will start listening for incoming requests. So basically starting up the server. Then as an optional argument, we can also pass in a callback function, which will be run as soon as the server actually starts listening. And so here, it's quite usual to simply display a message that the server has been started. So let's say listening to requests on port 8000. And so now all we have to do is to actually go to this URL on our computer on port 8000. Now before we can do that, of course, we have to run the Node application. So node index.js, and here we have our log. So listening to requests on port 8000. And you see that the app keeps running. So before, it was always stopping right away. So it did its work and then it exited the application. Right now, it doesn't do that. And that's because of something called the event loop that we're going to talk about a bit later in another section of this course. But no matter what the technical reasons are for this, it is obvious that the app cannot really exit right away, because then we could not receive any new requests, right? And so when we start a server, Node cannot simply exit the process, so exit the program, because the, the whole goal is to wait for requests to come in, right? So this is what I'm going to show you next. For now, let's just open up the IP address on port 8000. And for that, we use the colon and then the port number. So this is the host, which is localhost, colon, and then the port number. Hit enter, and here we go. So, hello from the server. And so yeah, it really works. You have a real web server now running on your computer using Node.js. Congratulations. So let's go back here and again analyze what happened here. So we created our server using createServer and passed in a callback function that is executed each time that a new request hits the server. And then we started listening for incoming requests on the localhost IP and then on port 8000. And so once we had all this running, we actually did the request by hitting that URL. So basically by hitting localhost on port 8000. And so then, under the hood of Node.js, an event was fired, which is something that, again, we're going to talk about a bit later. But what matters here is that this event then made it so that this callback function was called. Okay? And finally, as a result of that, we then got back this string. So now, just for the sake of curiosity, let's actually take a look at the request object. Okay? So we need to close the server and start it again because we did some changes to the code. And notice how this time I actually used Control-C in order to exit the application. So remember that in the beginning, when we used the REPL, I used Control-D in order to exit it, right? But now, when we have a Node program running like this, we need to use Control-C to basically break from that program, okay? And so again, that's why here I used Control-C, and throughout the rest of the course, when I want to finish a program, I will always be using Control-C. So that's Control and not Command-C again. So even on a Mac, you need to use Control-C. Let's now do this again. We get the same response, but now we should have something in the console. And so this here is the request object. And as I mentioned, there is a ton of stuff in here. You see? So all of this, it doesn't even fit actually in the console. Okay, so I think I cannot even show you like all the cool data that is in there. Or actually here we have some headers. So we have the host, and here we have some, again, so we have some HTTP headers, which is something that we're going to talk about, I think, in the next video. Okay, but anyway, what matters here is that we really get access to all kinds of stuff when we handle the request and send out the response. Okay, so it doesn't matter here. Let's actually get rid of this, give it a save, quit this, and start it again. And now, just to finish this video, I want to show you what we're actually going to build in the next couple of lectures, so until the end of this section. So it's this small fun app called the Node Farm, Okay, so we have a couple of products here, and we built all of this here using a very simple HTML template. And you can then click on the link, and it will basically take you to the detail page for this product. So in this case, the avocados. It then has a bunch of data here, a button, which doesn't do anything, and then we can go back to the page. So avocados, then we have the cheese, for example, and it has then, of course, different data for each of these products. So it has this nice, fresh, kind of crazy design to it to make it pop a little bit. And yeah, I think this is a fun little project, and we're going to start building it actually right in the next video. In this video, we're going to talk about and implement a concept called routing. So right now, the code that we wrote does not at all react to the URL that we're requesting. So let's say we have this URL and get this response, but if we have, for example, product, well, we get the exact same response, right? If we take a look at the example, the final project, well, here, for example, we see overview. So right now we have the host, then the port, and /overview. And so the route here is /overview. And then we see this page. But now take a look at what happens. So now we have product. And so that's why we get this product page. And when we go back, we get back to overview. And so we see again the page that we had in the beginning. Also, if we don't have anything at all, well, then we still see this same page. And so that is basically routing. So routing basically means implementing different actions for different URLs. Okay? And so right now we don't have anything like that. So as I said, no matter what URL we have, we always get the same response. And so we now have to implement some logic that changes that. Okay? And so again, that will be routing. Now, routing can actually become very, very complicated in a big real-world application. And so in that case, we used a tool for that like Express. So we're going to do that in the next big project in this course, where we use Express to do all of this. But for now, since we're just starting to learn Node, we want to learn how to do everything from scratch without any of these dependencies, right? So let's implement very simple routing here in this server. Now the first step is to be actually able to analyze the URL. And for that we use yet another built-in Node module which is called URL. And now I'm just duplicating this here and then URL. And just as a side note, so I selected URL, and then to select the next one, I just hit Command D on my keyboard. Okay, I know that someone is probably going to ask in the Q&A how I did this trick, and so that's why I'm replying to that basically right now and saying how it works. Anyway, first of all, let's actually take a look at the request.url, and of course I want a console.log of this. So stop the server and run it again. And there's a tool for us to automatically do this. I'm sure some of you will know that. And of course, we're going to use that a bit later. But for now, I want to keep doing it like this. Okay, so let's reload this. Works the same. And here we get the URL. Okay, and we actually get two of them. And what this means is that actually we have two requests, and so actually this callback function here is executed twice. So one console.log has just the slash, and the second one has /favicon. So when we're using a browser, the browser automatically performs a request for the website's favicon. All right. So in this case, we don't have any favicon, and we just ignore this, okay? So this doesn't really matter. Now let's say that we write /overview here. So let's see what we get then. So we get /overview and /favicon. Okay, so again, the one that matters is the /overview. So for simple URLs like this one, we actually don't even need the URL module, but we will need it for more complex stuff. So let's say that we have, for example, specifying the ID 23 and some other parameter here. Let's say this is something like this. And I'm sure you have seen this kind of pattern in a URL where we can specify parameters. So if we have something like this, then you see that the URL is this. And what the URL module will help us doing is to basically parse these parameters and their values into a nicely formatted object. Okay? So for now, we're actually not going to use the URL module just yet, but we're going to need it a bit later. So let's now actually implement the routing, and it's very, very simple. So basically, all we need is a big if-else statement here. Okay, so first of all, I'm actually going to save rec.url into a variable, into a variable called path name. Okay, and so now based on that path name, we will take decisions. So basically send back different responses. So if the path name is equal to overview or /overview, well, then let's send something to the client. Let's just say this is the overview. Else if the path name is equal to product /product, well, then all we want to do is to send this is the product. Okay. Now, in case we are at the root of the site, so basically like this, well, then we also want to show the overview. And so let's add that here as well. So path name equals and / and then the or. So if the path name is either the root or /overview, then send back that is an overview, or if it's product, well, then send back product. So very simple stuff, and let's test it out now. Actually, we can just reload, or instead, actually, we need to first finish this again and start it all again. So it's working already. This is the overview. If I now say product, then this is a product. Perfect. Now just to check the last one, overview gives us overview again. Okay, now let's say that we actually request something that we didn't handle. So something like this. So what happens? Well, as you see, this wheel here doesn't really stop spinning. So it's trying to send back a response, but it really can't. So the server doesn't know what to do in this situation because we didn't add any fallback. So let's stop this poor guy here and basically simply add an else statement here. So if it's not the root, not overview, not product, well, then we want to say that this page could not be found. Page not found. Now, many times when on a website you try to open a page that's not found, you see this 404 error, right? And that is actually something called an HTTP status code. And so since we're sending back a response, we can also add the status code to the response. And so for that, we can use multiple ways of doing that, but I'm going to use one that can do more than just status code. And I'm going to show you why in a second. But for now, I'm just saying here res.write the head and then 404. Okay, let's test that now. And so what happens here? Oh, indeed, nothing's happening because I didn't restart the server. So, page not found. So, great. Now, what about the 404 status code? Well, we can hit inspect here to open the DevTools, or instead, what I like to do is to hit Command J. And that will then open up the DevTools as well. On Windows, it's probably Alt Control J, or you can just come to View and then Developer and Developer Tools like this. Okay? Then head over to the Network tab, but actually you can already see it like here. So the server responded with a status code of 404 not found. But also you can see it in the network and just reload it. And then you see 404 here and the red text to show that there was some error. Okay? Now, something more that this write head here can do is to also send headers. And to send headers, we need to specify an object here, and then in there we put the headers that we want to send. Now, what actually is a header? Well, an HTTP header is basically a piece of information about the response that we are sending back. And again, you will learn a lot more about this in a later section of the course. Okay? For now, just know that there are many different standard headers that we can specify to inform the browser or whatever client is receiving or response about the response itself. For example, one of these standard headers is to inform the browser of the content type. So we can say content type and set it to text/HTML. And so just like this, the browser is now expecting some HTML. And so what we can do now, for example here, is to do an H1 element in order to basically send back HTML. So just like this. And because of this header here, the browser is now actually expecting HTML to come in. We can also specify our own made-up headers. So let's say my own header hello world. So something like this. Okay? Now what matters here is that these headers and also the status code always need to be set before we send out the response. Okay? So we never can send headers after the response content itself. So let's try that again, or actually I should restart the server. And so let's try again now. And indeed, we still get our error, but now it looks different. So now we actually have an H1 element here. And if we also on the network tab click on this request, okay, let's actually increase it a little bit here. So I'm not sure if you can really see this, but when we click on this request here, we can actually also see the response headers. And so here we have the content type that we specified as text/HTML, and then the other header. So my own header is set to hello world. And so again, we can use this to send some metadata about the response itself. All right. Now there were also some request headers, and these were set by the browser automatically. But for now, don't worry about these. What matters is that we specified that the content that we're sending is HTML, and also, for example, the status code that we send back as 404 not found. Okay, now let's just get rid of this, open it up, and so now you see we have a status of 200, which means, okay, and these other headers, they are actually gone. Okay, so now the response does not have these other two headers, right? And we see the 200k now, and so yeah, everything's working fine right now. We implemented the basic routing, so for different path names, we have now different actions. Just one final thing that I wanted to say about routing is that these routes that we defined here in our code and the routes that we put in the URLs in the browser have nothing to do with the files and folders in our project's file system. Okay, so as a beginner, you might think that if we open /templates, for example, that would then open the templates folder that we have in our file system. But of course, that is not the case. So if we wanted to have a templates route, well, then we would have to define that in our router basically, and then send a special response for only that route. Anyway, I think that this is enough for one video. See you in the next one. Welcome back. So I hope that you're enjoying this section so far and enjoying working with Node.js. So let's now move on in our project and build an extremely simple web API. Now to start, what actually is an API? Well, the long answer you're gonna learn in one of the next sections, but for now the short answer, at least in this context of web APIs, basically an API is a service from which we can request some data. So in this case, the data that the user wants to request is data about the products that we are offering in this node farm, so in this project. Okay, so I have here this dev data folder, and in there I have a JSON file. And JSON, in case you don't know, is a very simple text format that looks a lot like JavaScript object. So it looks like this, and we can have arrays, which we actually have. So we have one big array, which then contains these 5 objects. And each object then has the ID, product name, image, and so on and so forth. Now each of these has to be a string, so each of the keys, and then we have the value. Okay, so basically this data here is what our API will send to the client when requested. Okay, so we will have yet another route here. So right here, else if the path name equals /API. And for now, as a placeholder, we will simply send back API just like this. Okay, so what we want to do now is to actually read the data from this file here, then parse JSON into JavaScript, and then send back that result to the client. So something very simple, and so let's get to work. So the first approach of doing this is to come into this route and then read the file in here using the file read function, right? So let's start by doing that. So fs dot, and it's actually a read file, not file read. So read file, and then the name of the file. Now remember how I told you earlier that this here is not the only way of locating our file in the file system. Okay, let's for now actually use it still, but after we have it written here, I will show you another way. So in Node, this dot here actually refers to the directory from which we run the node command in the terminal. Okay, so again, this dot here right now represents this current folder here, because that is where we actually run the node command. So in this one node farm folder, which is our current working directory anyway in this case. But we could have run the node command somewhere else, and then the dot would mean something else. Okay, So for example, we could perfectly fine go to the desktop and run Node there, and then specify the whole path to index.js, but we could do that. But then, in this case, the dot would mean the desktop. So if we started the script from the desktop, then this dot would mean the desktop. And so that is not always ideal, and therefore there is a better way. So all Node.js scripts, they get access to a variable called dir name. And that variable always translates to the directory in which the script that we're currently executing is located. Okay, so in this case, it's actually the same place because index.js is also in this node farm folder. But again, for the reasons that I mentioned before, it is many times a better practice to use the dir name variable. So let's do that. And for that, we create a template string. And then we use the variable. So it is underscore dir name, so which stands for directory name. Okay, and so usually we do it like this. Now there is an exception to this rule, which is the require function. Okay, so when requiring modules, we can actually require our own modules. And we're going to do that a bit later, like in the next or one of the two next videos. And in there, the dot actually also means the current working directory and not the place where we're executing the script from. Okay, so just keep in mind that the require function is an exception to this rule, but usually the dot is where the script is running and underscore dir name is where the current file is located. Right? Now moving on, let's specify the UTF-8 file encoding and then our callback function, which is error first. Remember? And so we now have access to this data. Now the data is in JSON. And so in JavaScript, we have something built in which is called json.parse. And so this will take the JSON code, which is actually a string, and will then automatically turn it into JavaScript. So a JavaScript object or array in this case. So let's call this one product data. And then also quickly take a look at it. So in the console in this case. So restarting the server, and now don't forget to hit the /API route. And oh, what's happening here? Oh, we didn't actually restart the server. Okay, and so now we get the response API, and let's now take a look here actually at the product data object. So this is just a nice object with all the data that we had in this data.json file. All right. Now the next step is to then actually send back this data as the response. Now this response.end method here actually needs to send back a string and not an object here. Okay. And so in fact, what we want to send back is the data directly. So data is a string that we then transformed into an object using json.parse. But for now, we actually would not have need to do that, but I did it anyway because we will need this later when we start to build our HTML templates. Okay, so that is when we're going to need this data in a JavaScript format. For now, we just want to send back the actual string that we receive. Okay, now before we can do that, we actually need to specify, so we need to tell the browser that we're sending back JSON. Okay, so just like before, where we set the content type to text HTML, we now need to tell the browser that we're sending JSON. So we say res.writeHead just like before, and now we're using the status code 200, which stands for OK, and then the object of the headers. In this case, it's just going to be 1. So content type And when we send JSON, we need to say application/JSON. Okay, so for HTML, it's text/HTML. For JSON, it's application/JSON. And let's now take a look at that. Reload the server here very quick. And indeed, here we have our API, sending back all the data about our 5 products. So awesome, that's great. And it's great, but it's actually not perfect because it's not really 100% efficient. Okay, and that is because each time that someone now hits this /API route, the file will have to be read and then sent back. Instead, what we can do is to just read the file once in the beginning, and then each time someone hits this route, simply send back the data without having to read it each time that a user requests it. Okay? Does that make sense? Well, what I'm going to do is to put this out here. Okay. And of course, I don't need all of this. So this is not here, and this is not here. And actually, it will be kind of different. And that is because we will now actually use the synchronous version. And I know what you're thinking, which is that the synchronous version blocks the code execution, right? And while that is true, in this case, it is not a problem at all. And that's because the top level code actually only gets executed once right in the beginning. Only this callback function, for example, here the create server one. So this function here, this is what gets executed each time that there is a new request, but not the code that's out here. The code that is outside the callback functions, so the so-called top-level code, is only ever executed once we start the program. And so in that situation, it doesn't matter at all if it blocks the execution, because again, it happens only once and only when the code actually starts. Right? Makes sense? And so we're going to use the sync version now because it's actually easier to then handle that data, because that simply puts the data into a variable that we can then use right away. Okay? So don't worry about the fact that this function is blocking, because again, it is in the top level code and is only executed once. The secret here is simply to know which code is only executed once and only at the beginning, and which code gets executed over and over again and is therefore problematic when blocking the event loop. Okay? And of course, throughout the rest of this big course, you will learn that. Okay? So you will learn everything about the event loop and which code is blocking and which one not and why. And so this is just the first time I'm mentioning it, but it's not going to be the last time. Okay? You will hear me saying the same stuff over and over again. Okay? So just calling this one data, and then of course, we don't need any of this. Let's just move this here out. And that's it. So before anything happens, it will read the data from the JSON file into data. It will then also parse that into an object. Let's call it data object here. And so what we're going to do here is to not read this file each time that there is a request, and instead simply send back the data that we have now in our top level code. Okay, so this data here now comes from here, because of course this code in the callback function has access to the top level code because of the scope chain, right? So canceling, running again, and just to prove you that it still works. And it does. So perfect. And that's better, that's more efficient. Oh, and why did I close this? All right, let's just open it up again very quick. So here we go. So that is our very simple API, which now allows the user to simply request all the data about our application with one single API call, basically. Okay, so we added another route here, /API. Then we read the file synchronously, put it into this object, and then simply send back that object as a response. But before that, specifying that we're sending back application JSON, so that the browser knows exactly what to expect. And in the next couple of videos, we will actually start building the user interface. So that's the most exciting part, right? Let's now do the first part of building the dynamic node farm website, which is building the templates that will hold the actual data. And remember that our goal is to build this kind of dynamic website where we have an overview, where we have all the products, and then each product has its detail page, just like I showed you before. And this data here is of course read from the JSON file. So if we change the JSON file, for example, deleting one of these products, then reloading this page, then that product should be gone from here. Or if we changed some of this data here or the name, well, then that should update here on the site. Again, because it's a dynamic website built from the data that's in the JSON file. So, as I mentioned, the first step is to actually build these templates. One for this overview page and one for the product detail page. And we're going to start with the detail page. And I'm going to build these templates based on the static web pages that we have here in the templates folder. So let's take a look at them. So we have overview and product. And again, we're going to start with the product.html. So we have here the product name, then this image here, which is actually an emoji, but that doesn't really matter. So instead of having to request real images for all of these different products, I choose to just go with emojis. That's much easier. The same actually for the style. So I have all the CSS style inlined into the HTML pages so that we don't have to make multiple requests to getting these different data, right? Because actually each different file will trigger a different request, okay? Remember before where we had the request for the favicon, right? So we saw one request for the root, so for the main page, and then one request for that image. And what that means is that each asset, so each piece that is part of the website, will get its own request, and we would then have to handle that. And we don't want to do that, and so I simply inlined the style into these HTML pages. All right. So here's a bunch of style, and then here we have the name of the product somewhere. Yeah, here. So it's the name of the product. Here is the product image, which again is just an emoji, but it comes here from this image field. So we have this field called image, right? Then we have where it's come from, some of the ingredients, and the price. And also the description down here, okay? And again, all of this comes from these different fields. So let's take a look at the fields we have. So product name, image, from, nutrients, quantity, price, whether it's organic or not, and the description. So what we're going to do now is to basically replace all of these pieces that we want to add dynamically with a placeholder. And we're then later with our code replace that placeholder with the real piece of data. Okay? So let's start here with the product name. And so I'm going to go ahead and delete that and then put a placeholder here. And I can do anything that I want for a placeholder. I just like to go, in this case, with something like this. So product name, and then the percentage, and then the curly braces. So again, this could be anything that we wanted, but we want to find something that is probably not on the page so that we don't replace anything wrong. So anything that we actually don't want to replace, okay? And I could put something like this here, okay, and then replace all of that. But I think like this it looks nice and it's easy to recognize. And so all we have to do is to go ahead and put this all over here, and I'm then going to replace, of course, these names. So here we have the nutrient. Here we have the quantity. And here I have the price. Down here we have the price again, you see. And the price is just the number. Okay, the euro sign here stays right there, because the price that we have is actually just the number. Let's take a look at that right here in JSON. So we have just 650, but not the currency. And actually the same here. So let's grab that and copy it here very quick. And yeah, actually I forgot to replace this one. So this is from. And let's actually write out from, not in uppercase, so that this text makes a bit more sense. So for example, from Portugal or from Spain or whatever. Oh, what's that here? Okay, I guess I just wrote in the middle of product name. So nutrients. Okay. Oh, and down here we have, of course, the description. So let's replace that as well. Oh, of course, I need to get this one back. And so description. Next up, we have these images. So the avocado. And so I'm hitting a couple of Command Ds, pasting this here. And so I can edit these here all at the same time. Okay. Then image, and something here in the title we also want to replace the image up here and the product name also. So product name here, and here the image, so that this one as well will get replaced dynamically. All right. Now just one more thing, which is a bit more complex. Where is it? It's here. So some products are organic and some are not. And so there is a class in the CSS that will get added to all of these elements when they are not organic. Okay, so that is this class here. So when it's not organic, then it should not be displayed. So this organic badge here. And just to show you what I'm talking about, the organic badge is this thing here. Okay, so we do not want to display that in case it is false in the JSON. So what we're going to do here is to actually add another placeholder here, or actually inside of the class. And so I'm going to call this one not organic. And you will see why a bit later. Okay, when we replace this, it will make a bit more sense to you. All right, so I think this one is done. And I simply overwrote everything that we had. So let me now just call this template product. Okay, so this one is done. Let's move on to the next one, the overview. And this one is actually going to be a bit different. And let me show you why that is. So again, we have all the CSS inlined here. And now we have this cards container. And then for each of the products, we have one card. So each of these cards here has this figure tag, right? Now we actually do not know how many of these cards will be here in this overview, right? Imagine we have 10 products in the JSON, then we need 10 of these cards. But imagine that we only have 1 or 2, well, then we do not want all the 10 cards, but only 2. So how are we going to do that? Well, we will actually create just another template where there's only one card in there. And we will then include one of these templates for each of the cards that we want. So each of the products in the JSON file. All right, makes sense? So let's call this here the template overview. And I'm going to go ahead and create the template card. So what I'm going to do here is to now, as I mentioned, now it's back at the top. So I'm going to go ahead and grab one figure. That was too much. And paste it here. Bring this down a little bit. Okay, so each card now gets its own figure. Okay, and so now what I'm gonna do is to delete all of the cards from here and create a placeholder here as well. Product cards. Okay, so again, later on in our code, we will then create as many cards as we need here. For example, if we have 5 products, we create 5 cards like this. We will then put them together into one string and then replace product cards with that string, which contains all of these different cards. All right. So actually, we are done with this one. Okay, because most of the stuff happens inside of the template card. So nothing else to replace here. I'm just coming down here to copy this here. And so now it's very simple for us to replace what we need here. So this here is the image, and we actually have it twice. Okay, that makes it look a bit nicer. Image, image. Then here we have the product name. Remember, here in this place, we will have again the not organic placeholder. And again, this one will make more sense to you a bit later. More organic. Then the quantity here. Then the price. So we need to also actually build the link here. So this one here, so the A element, in case you're not really familiar with HTML, the A element is for a link. So let me actually show it to you in the real working example. So when we hover here on this link, down there in the left bottom corner, so down here, you will see that it is /product and then ID equals to 0. And this one is ID equals to 1, ID equals 2. Okay, and if we click on that, we see it actually here. So /product and then ID equals to 0. And this ID here is exactly the ID that we have in the JSON. Okay, so this one here. So the avocado has 1, the goat cheese has 1, sorry, the avocado has 0, of course. The broccoli has 2, and so on and so forth. And so here actually we need to build the link. So product, and of course not in uppercase. So product, and the ID is ID. Okay, so then we have to replace this ID placeholder here with the correct number. So 0, 1, 2, 3, 4, 5, and so on and so forth, depending on how many products there are. So suppose that we have a cheese here, okay, let's go back here. Well, then the image will be this here, the product name will be this, and the ID will be 1. Okay, and so this here will then translate to ID equals to 1, and or handler here. So this server handler here will then take care of going to the right page when the product ID is 1. Okay, so that logic is not yet implemented, but of course we're going to do that in the next couple of lectures. So we have now the templates actually built, and so let's move on to the next video where we will actually start to fill out the templates and send back the final page to the browser. So we already have our HTML templates. Now comes the hardest part, which is to actually replace the placeholders with the content. So let's actually start with the overview. And let's give ourselves some breathing space here and add some comments. So overview page, then some comments down here. So the product page, and then here we have the API. And then here we have the not found. All right, so that looks a bit better already. So again, we're starting with the overview page. And so the first step is to actually load the template overview. Okay, so each time there is a new request for this route, so just the root or /overview, the first thing that we're going to do is to read the template overview. But just like before, we can actually do that outside of this callback, okay? Because these templates, they will always be the same. So we can actually read them to memory right in the beginning when we start the application, and then when necessary, we simply go ahead and replace the contents in there. Okay, so just like we did with the data here. There's also no need to read the data each time there is a request, and the same happens for the templates. Okay, so I'm actually going to go ahead and do it for all 3 templates here, so we have that out of the way. So I'm going to go ahead and just duplicate this one, call it temp for template overview, and dir name, and here we have templates, and then /template overview. Okay, then duplicate this here twice. So we have one for the cart, so template cart, and then one for template product. All right. And again, keep in mind that we can do the synchronous version because we are in the top level code, which is only executed once right at the beginning when we load up this application. So we could not do this inside of this create server callback function, okay? Because this one is called each time there is a request. And if we had 1 million requests at the same time, then we would block the code 1 million times, once for each request. And that is something that we do not want. So the overview, let's actually go ahead and first of all, just to test it, send this temp overview as the response. Now, before we can do that, we need to go ahead and set this content type to HTML. So let me actually copy this piece of code here. So the status code is 200 and content type should be text/HTML. So restart the server here. And let's now take a look. And indeed, here we go. So here's our styled page that we already know from this one. Now what's of course missing here is these rows, and that's because we still have our placeholder. And so the next task is to now replace this placeholder with the actual cards. And how will we do that? Well, remember that in data object, we have an array of all the objects that are in data.json. So all of these 5 objects, all in JavaScript objects, because we already parsed this data, which is a string. Okay, so data object, again, is an array of, at this point, 5 objects. So what we have to do is to basically loop through this array, and for each of them, replace the placeholders in the template with the actual data from the current product. Okay, makes sense? So let's put that in code. So data object, we're going to loop through it with a map because we want to return something. And that something we will save into a new array. So let's call that one the cards HTML. Okay, and so I'm sure you are familiar with the map method. Okay, so what map does is that it accepts a callback function, and this callback function gets as an argument the current element, so the element of the current loop, and whatever we return here will then be saved into an array. Okay, so let's say we're looping over an array with 5 elements, which is the case here, and for each element we will return something, and that something will then be put into the same position, but in this new cards HTML array. So what will we do in each of these iterations? Well, we want to replace the placeholders, right? And so I'm actually going to go ahead and create a function for that, and it will be called replace template. Okay, and replace template will take in the card HTML, so basically the temp card, and it will take in the current object, so element. Okay, so this element is what holds the data, right? So again, each of these is now an object which contains the data in each of these properties. Okay, and don't worry if it doesn't make 100% sense now. It will once we create this replace template function. Okay, so let's now actually do that up here as well. So replace template is a function which takes in a template. It's going to call a temp here, and of course a product. All right. So let's create a variable called output, and that one will be template.replace, and now our placeholder. And we're going to put here all of the placeholders that we have, starting with product name. Okay, and so that one will be replaced with product.product name. So product, which is this argument that we passed into the function, dot product name, because, well, that's the name of the field where the product name is, right? So go ahead and copy that one, and all right. Now, one small trick that we have to use here is to actually not use the quotes, but instead use a regular expression. And that's because there might be multiple instances of this placeholder. And so the trick is to basically wrap this in a regular expression and use the G flag then on it, which means global. And so this will make it so that all of these placeholders will get replaced and not just the first one that occurs. So this replaces the product name. Now let's go ahead and replace all the other one. So output equals output dot replace, and now we'll just go ahead and copy this to make my life a bit easier. So image, and it is called image, and not in uppercase, so just like this. Okay, now up here I created this variable because I wanted to replace this product name in temp, so in the argument, and it's not a good practice to directly manipulate the arguments that we pass into a function. And so I created a new variable, and from now on I will then manipulate that first one, okay? And so that's why it's not a const, but a let. So a let we can mutate after it's been created, okay? Now let me just go ahead, copy a couple of these. So price, and it's called price here as well. Then we have from. Then we have nutrients. Of course, I could copy all of these, but I'm not going to jump back and forth here. So quantity, description. And I'm probably going to do some mistake here by writing all of this out manually. But in a small project, that's no big deal at all. So actually this one we don't need, or actually we do need, because for the organic. So the organic is missing, but remember the organic was a bit special. So in this case, if product is not organic, so product.organic, if it's false, so remember that is actually a Boolean. So for example, we have organic true here, but we have false here. Okay, and so if it is false, well, in that case, we then want to replace the not organic. So the not organic placeholder with simply not organic. So not organic because this is the class name that I showed you earlier. So it is this one. Okay, so it will then be replaced here. Okay, and so again, in case it's not organic, well, then the class name not organic will be here, and this entire batch will then be not displayed. All right, makes sense? So let's see if it, sorry, the actual code is below it. So let's try to make more sense of it. So again, we loop over this data object array here, which holds all of the products. And in each iteration, we will replace the placeholders in the template card with the current product, which is element, right? And this arrow function will then implicitly return it here. So it's the same as having return here, okay? But it's not really necessary because in a arrow function, if you don't have the curly braces, this value here automatically gets returned. Okay, so just in case you didn't know that, I just remembered that we forgot to actually return the output from here. Okay, so of course, we input the template and the product, but then of course we have to output the final HTML, right? And so that then gets plugged in here. And so then finally all of this here will replace an array with the 5 final HTMLs, each for one of the 5 cards. So each for one of the 5 products. All right. Now let's actually go ahead and log this to the console before we put it on the overview web page. So cards, HTML, just to make sure that everything works here. Okay. So we need to reload the server. Don't forget that. This all works the same, but now let's take a look at the console. And I'm starting to see nice things here. So we have an array, and we actually have the stuff replaced. So we have some avocados here. It says here fresh avocados. It has the 4 avocados per box, the price. And yeah, that actually all looks very nice. And indeed, it's also an array. So we have this first figure, then a comma, and so here starts the next element, so the next figure. All right, so we have right now an array of all these elements. But what we want is actually not an array, but we want one big string containing all of these HTML. So that's actually very simple to achieve. All we have to do is at the end of this array, so we remember all of this here returns this array that we see down here. And so at the end, all we do is join by an empty string. And so this will join all these elements into a string. And so now cards HTML is truly a string. Okay, and so now we have our cards ready. And the last piece of the puzzle is to go ahead and replace that placeholder. So this here, I'm actually copying it now. So now replacing this placeholder with the HTML that we just created. So let's call it output here. And all we have to do is temp overview, which is the string that holds the overview HTML, right? Dot replace, and replace it with cards HTML. All right, that's it. Now all we have to do is to actually respond with the output and not with whatever we had before. Okay, cool. So that looked a bit complex, but if you think about it, I hope that it makes complete sense to you. And so let's go ahead and test this now. And I hope I have no mistakes. And something went wrong. All right. So what's that? Okay, so I just misspelled replace. That's one of the most common errors I get all the time. Like some small spelling mistake. Reload, and bam, here we go. So here are our 5 rows. So beautiful, beautiful, beautiful. Now it doesn't quite look like the original one, because what's missing is like this organic here. Okay, so let's see what's wrong there. Also, for some reason, I don't see the quantity here, but only if it's not organic. Well, that's weird. So let's try to investigate what is happening here. So the error is probably somewhere here in this replace template function. But actually, everything looks kind of correct here. So also here on this not organic replacement. So let's take a look at our template card. And so I see here that when there's this not organic, well, actually this entire box here, so also this H6 will not be visible anymore. So something looks wrong here. Let's take a look at the original one, just to inspect the HTML here. So card detail is this one. And so we actually have 3 card details here, while in the template we only have 1. Okay, so let's go ahead and copy this one. So in the DevTools, you can actually copy an element, and it will then, well, just like that, actually copy the entire element. So this is what it's supposed to look like. And so here it should say organic and not quantity per box. Okay, that one is probably the next one. So let's quickly fix that. And here, of course, we do not want that. And so, yeah, that looks better. Close it up, restart the server. And let's check that one out again. And now, bam, here we go. So now it's working. And indeed, it works exactly the same. Beautiful. So that is really nice. Let's just go ahead and delete, for example, the avocados, just to see what happens. And I'm just going to do Control X to cut it, reload it here, and it's not changing. And that's, of course, because remember that this data is actually only read in the beginning when we start the app. Okay, so in order for this to take effect, we do effectively need to restart the application. Okay, so no big deal. And now it's gone. Okay, because it's no longer in the JSON file that is read at the point of time when we start the application. Okay, let's put it back here, give it a save, restart, open this guy up, reload, and here it's back. So it's now really working dynamically by reading all this data right from the JSON file. So this one works let's check the links also down there in the left-hand bottom corner. You see that the ID changes from 0, 1, 2, and so on and so forth. But if I click this here, well, then we get page not found. And so that's because our route is not yet ready for this, okay? And so let's actually do that in the next video and implement the product detail page for each of these products. So don't wait, and let's move on now. So in this video, we're going to learn how to parse some variables from the URL in order to be able to build the product page. So remember how right in the beginning I imported the URL module? So this one here, in order to be able to parse variables right off the URL. Okay, so as a first step, let's actually once more log rec.url to the console. And then another thing that I want to log is to actually the result of using url.parse on this URL. So again, parse is to basically parse the variables out of the URL. So something like this. So what we want is ID equals 0, right? Because right now, the rec URL is all of this. So this entire URL, and of course, we don't have any route for that. So nothing here in these kind of router that we have here actually matches this entire URL. And so that's why we get page not found. And so that's also why we need to change some stuff here. Okay, so let me parse the URL here so that you can take a look at the result to see what we need to do next. I also need to pass through here into this parse function in order to actually parse the query into an object. So with query, I mean this part here. Okay, so this is called the query string. All right, and so that's what we're effectively parsing, that part from the URL. So restart it. And let's just take a look at the logs that we get. So first is the rec.url, and this is what we were expecting, right? And here is the result of doing url.parse. So we get the query object here, and so here we have a nice object which tells us that ID is 0, right? So that's beautiful. And then right below that, we actually have the second piece that we need, which is just the path name. Okay, so our route is using this path name, so just /product, and then we need to know the query in order to respond accordingly to the ID of 0. So in this case, for example, loading the avocado product, which is the first one, right? But if it was number 2, for example, then loading this broccoli, right? And so this query and this path name is what we're going to use for doing that, okay? So this one we don't need anymore. We also don't want to log anything to the console now, because what we want to do instead is to create two variables called query and path name. And we can do so using ES6 destructuring. Okay, so again, I hope that you are familiar with this syntax here. And this is how it actually works. So this object here, it has a query and path name. And so by using this structuring like this with these exact property names, actually it has to be like this. So with these two exact property names, it will create these two variables, one called query and one called path name, and with exactly the values that we have here. So query will be this one, and path name will be /product in this case. Okay, now all I have to do is to go ahead and replace this here with this one. All right. Let's delete this one, and just to make sure, let's actually log the query to the console in case we are on a product page. Console.log the query object. And now we're back to finding the page. And we also have the query, which is ID 0. So perfect. So now we're ready to actually build this page using our template. And that should be very simple, actually way simpler than the overview page, because here we don't have to do any of these crazy loops over here, because there's one simple template. All we have to do is to replace everything. So, as a first step, let's actually figure out which is the product that we want to display. So I'm creating a variable called product, and that will be equal to the data object at the position query.id. Okay, makes sense? So data object is an array, and we will then retrieve the element at the position that's coming from the query ID. So if it's 0, then it's element 0. If it's 2, it is element number 2. Okay, and so this is the simplest way of retrieving an element based on a query string. Now, another thing that we need to do is to get this exact same head here. Okay. And now finally, we simply create our output. So output is simply replace template. And the HTML that we need to pass in is the temp overview, or actually the temp product. And what we pass in is the product. And that's it. Now we just send the output as a result, or as a response actually. And so that's it. So this part here makes sense, right? So again, replace template expects us to put in a template and a product. Okay, so a product is an object with all of these properties. And so that product comes here right from this data object. Okay, so in replace template, we pass in the template product. So this one that we loaded up from the file right in the beginning, and then the product. Yeah, as I mentioned, of course, the one coming from the array. And so that should actually be it. So if the template is correct, then this should be working now. So restarting the server, let's reload it. And indeed, here we go. So that is great. That makes me really happy when this kind of stuff works like this. Beautiful. Everything is perfect. Also this back button. Oh, that doesn't work. Okay, so we need to change the HTML template here. So where is that? It is in product. And this link here, where is that? Yeah, it points to nowhere basically. And what we want is to go back to overview. Right? Restart the server, reload this page, and now it works. Let's try out one without the organic badge. And indeed, it is not here. Before it was, and now it's gone. And all of this stuff here, of course, is dynamic coming from that JSON file. Yeah, so all of this works. Beautiful. That's really, really great. And our project, we can now say, is actually finished. Just one more small thing that I want to do, which is just to show you some nice thing that we can do. But besides that, our project is working. So congratulations, you just finished your very first really cool looking Node.js project. And it wasn't that hard, right? I mean, some of the things that we did are more like related to JavaScript programming in general and not so much about Node.js itself, right? So stuff like this here, which was maybe kind of confusing. But again, at the end of the day, that is just regular JavaScript really, isn't it? So again, the functionality is there. There's just one more small thing that I want to do in the next video. And when you reach that one, I will tell you what that is. So what I wanted to show you in this last video about the project is that we can actually create our own modules and export something from them, like for example a function, then import this function into another module and then use that function there. Okay, and so that is what we're going to do in this lecture. So let's say that we actually had a bunch of different JavaScript files in which we used this replace template function. So right now we are just using it here in index.js. We use it twice, and that is why we have a function. But imagine that we wanted to use this function in multiple files, okay? So what we can do is to create a new module and export that function from it and then import it back here. So the first thing that you need to know is that in Node.js, actually every single file is treated as a module, okay? And so this index.js here actually is also a module, which in this case imports other modules, and particularly these three. So let's now create a new folder here, which I'm going to call modules. And then in here, I'm going to create a file, which will be our module called replaceTemplate.js. Okay, so let's grab our function here, actually cut it out from here, and simply paste it here. All right, now how do we actually export this function from this module? Well, there are different ways of exporting something from a module, and we're going to talk in depth about all of this in another section later on. But for now, all we're going to do is to use module.exports. Okay, so in each module, we have access to a variable called module, and on there, we can set the export property. And that we then set to whatever we want to export. In this case, that is just this function. So we're going to get rid of this name. And so basically what we're going to assign to this exports property on module is simply this anonymous function, right? So I said anonymous because right now this function does not have any name. And so it's just an anonymous function that we assigned to this export property on the module object. Again, that is an object that we have access to in each and every Node.js module. All right. And again, later on, you'll learn how that actually happens behind the scenes. But for now, let's just use it and don't worry about why it works this way. So this exports this function from the module. Let's now go to index.js and import it. And imports usually always happen at the top of the file and after the core modules. So first we have the core modules, and then we have our own modules. Now, we will do require, and then our own module, which is dot. And remember that in the require function, the dot actually means the current location of this module. Okay, so remember when we talked about the dar name variable here, which is usually the one that points to the modules folder. But in this case, in the require function, remember there is an exception where this dot actually points to the location where this module is in. And so right now, that is this root folder here. And so from here, we go to modules. And then in there, we have replace template. And again, just as with the other modules, we don't need the .js. Okay, now that is going to return what we exported here with module.exports. Okay, so what we have here, this code, this function, is what will be exported from this require function call. And so we can now save that into a variable and give it any name that we want. So we could just call it x if we wanted, or really whatever we wanted. But instead, I'm just giving it this name that we already had here so that I don't have to change my code here. So replace template is the name that I want to give to this variable, which is now this function. And just like this, we exported something from one module and imported it into another one. Okay, and so if we now restart our server, everything should still be working, but it actually does not. We have some kind of error here. And it says it cannot find the module, and that's because I was stupid enough to call this folder here modules.js. So I'm sorry for that. This one is, of course, only supposed to be called modules. Okay, and that's why it wasn't giving me the autocomplete here. I was wondering why that was, and now we know. So if it doesn't work for you, just change the name here of this folder, and then everything should match and work as it should. So let's reload, and it still replaces everything as it should. The same here, of course. And so, yeah, we're now done with this project. So congratulations, well done, and you're well on your way of learning Node.js. Now in the rest of the section, we're going to talk a little bit about the Node Package Manager, or NPM. And so we're going to keep working a little bit with this project, but not really adding any functionality. Anyway, see you in the next video where we're going to start talking about NPM. So now that you know the absolute fundamentals of Node.js, let's take the rest of the section to talk a little bit about NPM, so the Node Package Manager. So the Node Package Manager is a command line interface app that automatically comes included with Node.js and which we use to install and manage open source packages. Now these packages that I just mentioned, they usually come from the package repository that is also NPM. So at npm.js, you can take a look at all the modules or packages that are included in the npm repository. So npm is actually both the command line interface app that we use to manage the packages and also the repository itself. Okay? And actually it's the largest software registry in the world, no matter what language we're talking about. And by the time of this recording, it has about 800,000 packages. So sometime in the near future, it will probably have over 1 million packages here on npm. So let's, for example, search for Express, which is the Node framework that we're going to use throughout most of the rest of the course. And so, for example, you can then click on it, and here you have all the information about each of the modules. So you can see that, for example, this one is downloaded almost 8 million times in the last week. And so you see that it's a hugely popular package, right? Then you usually have some documentation, but for now that doesn't really matter. So for now, we're just interested in what NPM actually is. And probably you have used NPM yourself before when working on front-end development, because these days NPM is actually not just used for Node development, but really across the entire JavaScript stack. So for example, if you search for React, it's also going to be here. So really all these popular libraries and frameworks, they are all really on the NPM registry, okay? So basically npmjs.com is where all these packages are hosted. Now about the command line interface itself, it actually comes already pre-installed with Node.js. And so let's now actually start using it and go back to our project. So here we have still our terminal open, but I'm gonna quit now this process here. So I hit Control C and then clear the terminal. So again, NPM is a software that we basically use to manage the third-party open source packages that we choose to include and use in our project. And the first thing that we usually do whenever we start a new project is to start with npm init. So we use npm as the command and then init. And this will basically create a package.json file, which is kind of a configuration file of our project where all kinds of data about the project is stored. Okay, and we're going to see more about that once that is finished. So npm init is now asking us a bunch of questions, as you see down here. And maybe if you're not seeing it, I will increase this a bit. So first thing that we need to specify is the package name. And this one is called node farm. So we need to use a URL-friendly name here. So that's why I have the hyphen. And what you see here is the suggested name, but I don't want the 1 in there. So I just retyped node farm here. Then we have the version. So we can just hit return here on this one. Then the description, learning Node.js. The entry point is index.js, but again, this doesn't really matter. We don't have any test command, so just hit return again. No git, keywords, doesn't really matter again. The author is me. You can put your own name, of course, and the license. And so one last OK to confirm that this is the file that we want. And so actually it created it right away here on this left side. Bring it down again here. And so indeed, this is our package.json file with this very basic information about the project for now. But there is a lot of stuff that can be added to this file, and we will do so later in another project, and also right in the next video, which is where we're going to start installing packages. And these packages are then also registered here in this file so that we can keep track of all the packages that we're actually using. Okay, so in the next video, we're then going to finally install some real packages here. In this video, let's take a look at the two types of packages that we can install with npm and also the two types of installs that there are. So the two types of packages that we can install are simple dependencies or development dependencies. Now, simple or regular dependencies are simply packages that contain some code that we will include in our own code. So code upon which we build our own applications. And that's why we actually call them dependencies, because our project and our code depend on them to work correctly. For example, Express, which is again the Node framework that we're going to be using later in the course, that will be a dependency. Okay, so let's now install our very first dependency just to show you how it works. And the package that we're going to install is called Slugify, which is a small tool that we can use to make more readable URLs out of names. For example, like product names in the case of our Node Farm example. So in order to install a simple dependency, in npm, all we have to do is say npm install and then the name of the package, which is simply Slugify. Okay? In previous versions, you would also have to say -- save, like this, but right now that's no longer necessary. And so if you just specify npm install Slugify, it will then install this package as a regular dependency. And watch what happens to our package.json file once that installation is done. Okay, so we'll hit return now, and let's see what happens. And actually that was really fast, and it installed our package right away, and then created this new field here called dependencies, and put our first dependency, Slugify, right in there. Okay, it also then has the version of the package, but we're going to talk a bit more about that later in this section. All right, so this is our first dependency, and again, this is just a regular dependency. And we will use Slugify right in the next video. Okay, so just to get a sense of how we use these third-party dependencies in our code. But right now, what I want to show you is that besides these regular dependencies, we also have development dependencies. And these are usually just tools for development. For example, like a code bundler, like Webpack, or a debugger tool, or a testing library. So these are development dependencies. They are not needed for production, so our code does not really depend on them. We simply use them to develop our applications. So let's now install a dev dependency, which is just a short name for development dependency. And the tool that we're going to install is called NodeMon. So npm install NodeMon like this. And then what we have to do to specify that this is a development dependency is to say save dev. And so this will then add an entry to this package.json in the dev dependencies. So let's actually take a look at that. Okay, so once this is done installing. Now NodeMon is a very nice tool that helps us develop Node.js applications by automatically restarting the Node application whenever we change some files in our working directory. Okay, so remember that in the project, I was actually closing down the server all the time and then restarting it each time that I was changing the code. But with this tool, that's no longer necessary. So it will automatically restart the server each time that we do a change. Okay, so it's now done installing, and it created a new field called dev dependencies, and then of course added NodeMon in there. And so our project now basically knows that we depend on this tool here to develop our application and this package here to actually build our code base. All right, so these are the two types of packages. Now let's also talk about the two types of installs of these packages. Because right now, all we did was to install these packages locally. Okay, so they only work in this project. And we can actually see that right here in our project folder because npm created this new folder called node modules for us. And so it has all the dependencies of our project. But now you might ask, well, we only specified Slugify and NodeMon. So what are all of these packages doing here? Well, that's simply because they in turn are dependencies of our dependencies. Okay, so if for example Slugify needs one of these packages, well, then npm will install these dependencies as well. And so we end up with all of these dependencies here in our project. All right. So these are our local modules. So Slugify and NodeMon, again, we just installed them locally in our project folder, and they're not going to work anywhere else. But with npm, we can also have global installs. And global installs will then be available anywhere, not just in our project folder, but in every folder across your entire machine. So a package should be installed globally when it provides an executable command that you can run from the command line interface. And NodeMon, for example, is one tool like that. So I use NodeMon in all Node projects that I work on, and so I have NodeMon installed as a global dependency, because that way I don't have to install it each time that I'm creating a new project. I can simply use it in a new project because it's already installed globally. Okay, so let's not actually do that. Clear the console here, and then install it globally. So npm install, and that's actually a shorthand for install. It actually is enough to just write I like this. Okay, and so that's actually usually how I do it. So npm I NodeMon, and then the flag global. Hit return now, and so now it is being installed globally. But it actually gives us this error. And if you're on a Mac and did it like this, then it will also give you an error, simply because you don't have the permissions to install this package. Okay, so if you're on a Mac, it doesn't work, and I believe on Windows it should work. At least that's the experience that I have. But if you're on a Mac, you have to actually put sudo in front of it and then put in your password. All right? So basically just to give it permission. Well, in my case, I have Touch ID, but yeah, if you don't have that, you can use your user account password. Anyway, now that works, and we can now start using NodeMon on this project. So let me actually show you how it works. So before, to run our app, we did it like this. So we wrote node and then index.js. What I did here now was actually an autocomplete, and I think I hadn't talked to you about that at this point. So let me go ahead and delete this. So I started typing the I here, and since there is no other file which starts with an I can now hit tab, and so it will automatically complete the rest of the file name for me. So we used to do it like this, then hit return, and then whenever we wanted to do some change, we would have to exit it like this and restart everything again. But that's no longer the case because now we have NodeMon. So all we have to do is to, instead of writing node, we write NodeMon and then index.js. Okay, and so now it's watching every file with every extension. All right, so if we go now back to our file here, we don't even need to change anything. All I have to do is to give it a save and take a look at what happens down here in the console. So I will save it now, and you see restarting due to changes. And so now it started again, node index.js. So you see that behind the scenes, it is actually still running the original command that we used to do. So node index.js. And so NodeMon is basically just a wrapper around that node command, simply to make our lives a bit easier. All right, so this is an extremely handy tool for us to work with Node. And for the rest of the course, I will always be using NodeMon instead of the node command. And now, just to finish, there's one more small thing that I wanted to show you here. So let's say we didn't install NodeMon globally. Well, how would we then use our dev dependency here locally? So the local NodeMon that we have installed. Well, we couldn't simply run it from the command line because the local dependencies, they don't work like that. We cannot simply use them right away in the command line. But what we can do is to specify an npm script. All right, and we do that here in this script field. Now, when we did npm init, it actually put this one script here for us, which is for testing, and then simply said that we don't have any tests specified. So that is just like a placeholder for us now, which we can replace now with start, and then NodeMon index.js. Okay, and this NodeMon that I'm using here will actually be the NodeMon coming from the dev dependencies. So instead of writing the command down here in the command line like I did here, I will simply put the same thing into an npm script. Okay, and the script is called start in this case, and now we will be able to run that. So let me finish this one here. And so this is how we run an npm script. npm run and start. And indeed, it gives us the command here, NodeMon index.js, and now everything works the exact same way as before. Right? And this has nothing to do with the fact that we installed NodeMon globally before. It simply works like this because, again, NodeMon is our dev dependency right here in the npm script, we can then write something like a command line interface instruction that is going to use that local dependency and not the global one. So again, this would have worked just fine without nodemon installed globally. So this is how you specify npm scripts, and we will do a bunch more throughout this course, and we can give them all sorts of names. Start is kind of a default one for development. And so actually for start, we don't even have to write npm run start, but writing npm start is actually enough to trigger this special command. So you see again, it works just fine like this. Perfect. So in this video, you learned the difference between regular dependencies and development dependencies, and then you also learned that you can install them either locally or globally. Or you can also install them in both places, right? But actually, usually the global dependencies that we install are usually always development tools, because they are the ones who make more sense to install like that. Again, because they usually provide us like a nice command line interface program. In the next video, we will then use this dependency that we installed here actually in our code, so that you learn how to actually include a third-party module into your code. So far in this section, you learned how to require Node.js core modules, how to require your own modules, and so in this video you're going to learn how to require third-party modules from the npm registry. And actually requiring a module that we already installed from npm is really simple. So again, we do all the requiring at the top, and usually we require the core modules first, then the third-party modules, and then our own coming from our local file system like this. So the one that we are going to require is called Slugify. Remember? So this is the one that we installed in the previous lecture. And all we have to do to require it is to, just like before, use the require function and then simply the name of the package. And the Node.js will automatically know that it will have to go into the Node modules folder, so this folder where all the dependencies are, and search for that module there. Okay, so again, this will then return a variable, and so we need to save that into a variable. And I'm calling it Slugify here, just like this. Okay, and so Slugify will be a function which we can use to basically create slugs. So again, what is a slug? Well, slug is basically just the last part of a URL that contains a unique string that identifies the resource that the website is displaying. So for example, in our node farm, let's say that when we opened this avocado, instead of having like this ID equals 0, we could have something like fresh avocados, okay? And so this part here, or actually just this part, so this would be the slug. So it's basically this name here, and then based into a unique string like this. And I'm sure that you have seen this all over the place, like in blog posts. It's very common to do it like this, or really anywhere where we do not simply want like something like this. Okay, so ID equals 1, or we could also just use, for example, in this case here, goat and okay, and so on and so forth. Okay, I'm not going to type out the entire name, but the idea is to use a slug, which is this, so a unique string, instead of just the number, which is not meaningful to us at all. Now, let's say this is the first time that you're using the Slugify package. And so in order to figure out how it actually works, we can search for the documentation here on npm. So we just put the name of the package here, then search for it, and so this is the one that we did install. All right. So we already did this part here, so requiring the module or the package here. And then down here we can see how we use it. So all we have to do is to use slugify as a function and then pass in a string. Then down here you see the options, and for example we can specify the replacement, so basically what the empty space will be replaced with, and usually that's this dash, so just like I was typing here. But we can specify something different, like an underscore or nothing at all. Okay, here we can specify that we want everything in lowercase, and so let's actually go ahead and do that now in our code. So we have slugify here, and now just to test it, let's do it here before we create the server. Console.log, slugify the string, fresh avocados, and then I'm going to specify the option that I just showed you, which is lowercase, and set it to true. Give it a save. And remember that now no longer we have to close the app and restart it again. NodeMon does that automatically for us now. And so down here you already see fresh avocados. I simply did some mistake here, so it's lowercase, but it's still not working for some reason, so let's go back here. And oh, I see, it's actually just lower. But that's exactly what the documentation is for. So for us to see how something really works so that we can use the package correctly in our code. And so just like this, I created a slug out of our initial fresh avocado string. Let's now just do that for all of our products. So they are in data object, so let's create an array of all the slugs. So slugs, so data object dot map, and so this is again just regular JavaScript, so that shouldn't be nothing new to you. So we're looping over the data object and then create a new array based on that. And in each iteration, what we're going to do is to take the element and then create a slug out of that. So slugify element dot product name. So remember, that is where the name of the product is. So here you see product name. And so then this option. And let's actually log that one to the console. And indeed, here we go. So these are our 6 slugs, or actually just 5, out of our 5 products. All right, and so this is how we include a third-party module, take a look at the documentation, and then use it actually in our code. Okay, so this slugify is now a dependency of our code, because without that package, this piece of the code here would now no longer work, right? So our code now depends on having the slugify package installed in the project. Now we could go ahead and actually store these slugs here into the data JSON and then build the app so that instead of the ID, it displays the slug in the URL. But I'm not going to go ahead and do that here because that's just using the same concepts that we learned before all over again. And so that doesn't add nothing new. All I wanted to do in this video is really to show you this process of integrating a new package into our code, taking a look at the documentation, and then just do a simple example with that new module. So that was the goal of this video. That is completed now, and so let's now move on to the next one. In this lecture, we're going to talk about a bunch of more stuff that you should know about working with NPM packages, such as versioning, updating, or deleting packages, and also some other stuff. So let's get started. And the first thing that I want to talk about in this video is these version numbers of our packages. So most of the packages on npm follow the so-called semantic version notation, which means that their version numbers is always expressed with these three numbers. So the first one here is called the major version, then the second one is called the minor version, and the third one is called the patch version. And there's actually a meaning in these three numbers. So the patch version, which is just this last one here, is only intended to fix bugs. So let's say that in version 1.18, the developers found a bug, and so they fixed that bug and then released 1.18.1. Okay, then they found another bug, and then they released 1.18.2, and so on and so forth, until they reached 1.18.11, which is the current version number. So again, this last one here is just for bug fixes. Then after that, we have the minor version. And the minor version introduces some new features into the package, but it does not include breaking changes. So all the changes that are done in a new version number will always be backward compatible. Okay? So if one day the NodeMon team, for example, decides to release version 1.19, well, that will then include some new features, but it will not break our code. And the same, of course, happens with this one here. So if someday there is Slugify 1.4, well, then our code is still going to work the same. There will not be any breaking changes. Simply there will be something new, so some new features, which are not just bug fixes. Right? So bug fixes again are for the third, so for the patch version, and then minor new features are for the minor version. Then of course we have the major version, which is only bumped up whenever it is a huge new release which can have breaking changes. So for example, if Slugify 2 comes along, well, our code might no longer work because the Slugify function that we have here, for example, might have changed its name, or maybe the parameter that it expects here are different, or the options might have changed, or something might have changed that will break previous versions. Okay? And so be aware that when there is a new version, it might usually affect the code that you already have. All right? And so because of that, it is also important to talk about updating packages. So in our package.json file, this small symbol here that comes in front of the version number is what specifies which updates we accept for each of the packages. So this symbol here, which npm specifies here by default, means that we accept patch and minor releases. Now, how do we actually update packages? Well, let's actually quit this process here. And the first thing that we can do is to check if there are any outdated packages. So we write npm outdated, and that should then give us actually a table with all the packages that are outdated. Well, right now they're all up to date, and so that didn't really happen. So what I want to show you now is that we can actually install a certain package with a certain version number. So let's do that with the Slugify and install it at version 1.0.0. So npm install Slugify and then add 1.0.0. So let's try that out. And so now indeed we have 1.0.0. Okay, when we hover it, it actually says latest version 1.3.4, which is what we had before, right? But if we now run npm outdated, it should then give us that. So we see that current is 1.0.0, wanted is 1.3.4, because that is the one that we accept. Because remember that with this here, we accept all the patch and all the minor releases. But of course, we can also change that. So for example, we can set it to this symbol here. And this will then only accept patch releases. So this one is a bit safer. So if we run npm outdated now again, let's see what we get. And so now the wanted is only 1.0.2. Because again, we only accept minor versions And so 1.3.4 is not accepted by us because, well, we do not accept any of the minor releases. So again, just patch releases. So if we were to do npm update Slugify now, let's see what we got then. And so now we're at 1.0.2, and you see that it changed back, or like updating configuration here to accept minor and patch releases, not just the patch releases like we had before. So if we're going to run this now again, it should actually bump us up all the way to 1.3.4 like we had before, right? And indeed, here we go. All right. So that is how we update packages. And there are other configurations that we can choose here. So we can say, for example, that we want all of the versions. So if at some point there is a version 2, and if we then update our packages, it will then automatically bump our version up to version 2. So this one includes all the versions, right? Even the ones with breaking changes. But that's not a good idea usually. And so I usually just go with this one that is default, or sometimes even this one here. Because at some points, even if a minor release should simply introduce new features, but no breaking changes, we know that sometimes there can be bugs that developers do not found, and then these bugs, they find their way into our code and might break our code. And we do not want that, of course. And so the safest version is to just use this one for bug fixes. And so let's actually just keep it like this here, just for demonstration purposes, all right? And so this is what you need to know about version numbers and updating. But we can, of course, also delete packages. So let's now go ahead and install Express. All right, so just so that we can then go ahead and delete it after that. And I'm sure that you can guess how we can do that. And so that is very easy. npm uninstall, so it's actually not called delete, it's really uninstalling. So we install and we uninstall Express. Okay, and so that will then delete it from our node modules folder and also from our dependencies in the package.json file. Okay, so each time we decide not to use a module anymore, well, we should always go ahead and remove it, or actually uninstall it. And now as a final thing, I want to talk a little bit about the node modules folder. So this folder, which contains all the dependencies of our project. So let's say that you want to share your code with someone, or that you, for example, want to start working on one computer and then move to the next one. You will never share this node modules folder, because this code, you can easily get it from npm. There's no need to go ahead and copy all of this code here, for example, to a GitHub repository or to a Dropbox folder, or really somewhere that you want to share your code. Because this folder here, as you see, has tons of folders, and each of them might have tons of files, and all of a sudden you might end up with tens or hundreds of thousands of files. And so you should never share this folder and never check it out into your GitHub repository. So let's say that you uploaded this code to your GitHub account without this node modules. Or you put it into your Dropbox at one computer and downloaded it at the other one. So let's say we now downloaded this code here, so without node modules. So we delete that one now and end up with just our regular project folder. So how do we now get back our dependencies, so our node modules folder? Well, it's very easy. All we have to do is npm install. So what it did is to read our package.json file, read our dependencies, and then download everything back into this folder. All right. Now, one important piece of this puzzle is the packagelog.json file. So if we open that up, we get a list of all the versions of all the packages that we're actually using. And that includes the dependencies of our dependencies. So let's go to Slugify, for example. Slugify. And so here we see that we're using version 1.3.4. And so that is very, very important, because if you share your code, you want the other developer or even yourself to be using the exact same package versions, so that your code works the exact same way for you and for the other developer. And so for that, the exact version numbers are basically set in stone in this package log.json file. Okay, so if you share your code, no matter if you're using GitHub or Dropbox or something like that, always share your package.json file and the package log.json file, because these two files are necessary for the other developer to then reconstruct basically the Node modules folder. All right. And yeah, I think that's all you need to know about package versions, updating, uninstalling, and also sharing code with npm, package.json, and package log.json. If there's anything more that you want to know, you can again always ask in the course Q&A, and then you will get help there. So this section and the Node Forum project are now basically completed, but in this video I wanted to very quickly go over my VS Code setup and also together with you set up the Prettier extension. And so these are the extensions that I have installed in my VS Code, and not all of them are going to be relevant for this course, but whenever there is a relevant extension, I will mention it by the time that it is useful. For example, this .env extension here will be useful to highlight environmental variables in a .env file. So let's just quickly go over some of them. For example, ESLint is useful to find bugs in our code, and actually we're going to set up ESLint with Node a bit later in another section. We have image preview, which is a very nice small extension to preview images, and maybe you have noticed it when we were doing this. For example, this template here, you see that here on the left side it displays all the images that we include in a website. So in this example, it is this one. All right, so just something small that I found very useful. What else do we have here? We have Prettier, and so this is the one that I want to config with you in this video. But for now, let's go over some other here. So Pug is a language that we're going to use later to build templates, and so it's useful to have this beautify extension for that one as well. Then I also have tab9, which does some nice magic autocompleter sometimes. Then I also have to do highlight, which is very useful to do this kind of magic here. For example, when I have to do, it will highlight it in this green color, or if I write bug like this, it's going to turn red, or fix me. And I have all kinds of these keywords here that I have defined with different colors to make them visible in my code. And it even shows up here on in this scroll bar. If I had these in different lines, then you would see the three colors are now here in this side, and this is incredibly useful. All right. And then, of course, my VS Code theme, which is Oceanic Next. So I get this question all the time. And so instead of asking it, well, here is the answer for that. All right. But now about, where is it? So Prettier. This is a very nice extension that can automatically format our code, no matter if JavaScript or CSS or even HTML. With this extension, we no longer need to worry about formatting. And it is actually very opinionated, so it follows a very strict set of rules with only a small configuration possible. But in this case of code formatting, it's actually very nice when someone else takes these decisions for you. So that is one less thing that we have to worry about doing. Okay, so our code will automatically format without us having to do anything or worrying about a certain style. Okay, so if you want to give it a try, please go ahead and install it now. Here, probably you have a install button. I, of course, already have it installed. Next up, what you need to do in order to get the full power of this extension is to go to your settings and then activate format on save. So just search for format and then format on save. So whenever we save a file now, it will automatically use Prettier to format our code. So we installed Prettier, we enabled format on save, and now we can configure Prettier a little bit. Again, as I mentioned, it's very opinionated, so there's not a lot of stuff that we can change, but some things we actually can change. Now, we could do that here, right in VS Code, but instead, what we can also do is to define a configuration file. Okay, and I find that actually better to do. So instead of using VS Code to define the settings, we can use a Prettier config, which is called Prettier RC. All right, so it has dot and then Prettier RC. Then we open the curly braces, and then in here we can define some settings. And I find it better to do it like this because then I can change configurations from one project to another. And even more importantly, it makes it easier for multiple developers on the same team to all use the same configuration. Okay, so that can be very, very useful on teams, even more useful than when you're just working on your own. Now, the only setting that I actually want to change here is called single quote. So actually Prettier already has this auto-completion built in, and so it knows that single will mean single quote. And the default is false, but I want to set it to true. And so what that's going to do is that all my quotes will change from double quotes to single quotes. Okay, so I gave it a save, and here is our index.js. And now let's see if there is any double quotes here. And I think they're not, because I pretty consistently use the single quotes anyway. But let's just put some double quotes somewhere here. And now I'm going to give it a save and take a look at what happens. Whoa, so first of all, you saw that a lot of stuff changed here. And so our code kind of jumped around here. But this is where I had the single quotes here. And so you see that they are back to being the double quotes. Now, all this code jumping around was probably because at some point I had multiple lines, and Prettier does not allow that. So if I have something like this and give it a save, then Prettier will only allow one blank line. And actually this was for me the most difficult change of all the formatting that Prettier does, and it's not configurable. So we cannot change that, unfortunately, because sometimes I like to have multiple lines, but with Prettier that's just not possible. I can do something like this, and then it's going to work, but it's just a workaround. But still with this problem, I really prefer to use Prettier. Again, because it takes the thinking of formatting away from me. For example, something else that I did here was this. So whenever a certain number of characters in a line is exceeded, it will then find a good way of breaking the code into multiple lines. So that's what it did here. Let's see what else we have here. Well, I think besides these changes that we just saw, everything kind of remained the same. Okay, and so from now on, in all the rest of the code in this course, I will always use this Prettier RC configuration file with autosave on true. Okay, another thing that I didn't mention is that it automatically puts the semicolons. So if I go ahead and delete this one, and this one, and this one, give it a save, you see that they are back. All right. Now, if you want to get an overview of all the stuff you can configure with Prettier, well, that's very simple. If we write Prettier into Google, so they position themselves as opinionated code formatter, like I told you before, and down here we have the options that we can actually configure. So the print width, the tab width. So if you're one of these people who uses for width, which I actually was until kind of recently, like 1 year ago, well, then you can configure that using the tab width. Then you have, for example, the quotes that we just changed. So single quote, we put it to true, and you have all kinds of stuff. You can actually see it here on the right side. Okay, but again, it's not a lot of configuration, so most of the stuff you can really not change. Another thing that we can experiment with is the tab width. So let's set this one to, I think the default is 80. Let's set it to something like 120. And I thought this would change this piece of code here. So being back to what we had before, everything in one line, just to show you. But maybe our line is actually even longer than that. So let's put something really ridiculous here, like 200. And whoa, what's happening here? Oh, so you see that actually it now changed to something even weirder. Okay, so I never did this kind of experiment. Put it back to 120. And what's going on here? So let me just quickly fix this. And it does it again. All right, put it back to 80 as we had. And now it looks like this. Oh, yeah. Oh, I'm sorry. That's not what I wanted to do. Of course, I didn't want to change the tab width, which by default is 2. I wanted to change the print width. So basically how wide one line can be. Oh, that was really stupid. So now it's back to normal because the default is 2. So yeah, now you see that it actually got back into one line here, because at this point here we are at column 96, as you see down here, and so the limit is 120, and so it didn't have to wrap this line of code into the second one. Okay, but I actually like this 80 limit, and so I'm going to put it back here and use that one in the future. So actually that's the default, so let me just get rid of it. Give it a save, and so we're back to the way it was before. So if you think that you like this, then please go ahead and use it just like I do. But if not, well, then just kind of ignore everything that I said in this video and just keep doing it the more normal way. So that's no problem as well. Now that we reached the end of this first section, I want to do a very quick recap and also talk a little bit about what's ahead of us in the next 1 or 2 sections. So over the last 20 lectures or so, you already learned a bunch of really cool stuff. So you learned how to read files, how to write files, you learned how to require, so how to import modules from Node's core or your own modules or even third-party modules, right? Then you learned how to create a web server, yeah, like we did here. In there we did some nice routing, we did templating, and we built this really nice website here, which I think is pretty cool. So that's a pretty great result for just this small amount of lectures, I hope. So congratulations really on finishing this section and on doing great work and great progress. Okay, I hope all of this made sense to you and that you came out of this very first section already with some good fundamentals about Node.js. So if you feel like it, you can go ahead and create a small demo project for yourself using what you learned here. And I think that would be quite a nice challenge and a great exercise for yourself as well. Now, next up, we actually have 2 sections which are actually a bit more theoretical. So the first one is about back-end web development, and the second one is a deep look behind the scenes of how Node.js really works. There's also some coding in there, but mostly they are really theoretical. And I did include them because I really want you to deeply understand how Node.js works, and all my students, or at least most of them, really love these kind of videos in all my other courses. And so of course I had to also include them here in this course. And they are in fact really important for you to understand not only how Node works behind the scenes, but also to get a better understanding of all the rest of the material that's going to be in the rest of the course. It took me a lot of time to put together these videos, like actually a couple of months to be honest, and they follow a very logical and clear structure so that one topic builds on top of the other. Okay, so to make your learning experience as smooth as possible there. And so I really hope that you do like them and that you do not skip them. Now, if you're the kind of person who really does not like to learn about the theory of stuff, please just go ahead and skip these sections and go straight into the section where we start learning about Express. That's much better than just leaving a bad review like some people do. Okay? But in case you're interested in really knowing how Node works, then come with me into this deep dive that we're going to start right in the next section. See you there.